Hey guys, Mr. T here. This is another video. This one is on constructing constraints. Now, so far, all we've done is draw feasible regions from provided constraints. So the questions have given you the constraints pretty straight, so it's been easy to draw them out. But in worded problems, it's going to be much more complex, and the constraints, you need to interpret them from the situation provided. So, sometimes it can be helpful for you to tabulate the given info and to organize it in such a way. It makes it easier to devise the constraints for all the relevant variables in the given situation. So this is just an example of a shortcut. You don't need to tabulate all the info to get constraints, but it can help you organize it. So if you're in a pressure situation and you're freaking out, you don't miss anything. So the example I'm going to do is the one from the book. A cabinet maker produces 2 drawer and 5 drawer filing cabinets. Cabinet maker has 34 drawers, 8 locks, and 42 square meters of sheet metal available, so that's what he's got in stock basically. Each 2-drawer cabinet requires 1 lock and 2 square meters of sheet metal. Each 5-drawer cabinet requires 1 lock and 4 square meters of sheet metal. So he's got 2 different kinds of cabinets available. They require different amounts of material. And so the constraints are going to be defined by the amount of material he's got in stock and the amount of material that the things that he's making require. Let X be the number of 2-drawer filing cabinets made, Y be the number of 5-drawer filing cabinets made, and what I'm asking you to do is construct a table showing the relevant info and also construct a set of constraints defining the problem. So we're not going to graph this, we're just practicing setting up constraints from a worded problem that we may draw eventually. So the first step to this is to identify the variables that are setting up the constraints, and there's going to be different constraints here because there's different kind of materials with limitations. The amount of material that they've got constrains or limits the kind of things that they can make. So the first one that I'd identify would be you've got 34 drawers. And that is limited. That's the limit to the number of drawers that can be in these cabinets, because some of them take 2, some of them take 5, and they're only going to make as many of them as they can. That's going to take up those 34 drawers that he's got ready to go. That's one of your constraints, the 34 drawers. And it's linked to the fact he makes 2-drawer cabinets and 5-drawer cabinets. Another constraint that we've got is the locks. So he's got 8 locks to play with, and each of the 2 different kind of cabinets require 1 lock each. So the number of cabinets he can be making is going to be limited by the number of 8 locks that he's got to use. And the last constraint that you've got here is the amount of sheet metal they've got. He's got 42 square meters of sheet metal available, and the 2 different cabinets require different amounts of sheet metal. 2 square meters for the 2-drawer filing cabinet and 4 square meters for the 5-drawer filing cabinet. So we have identified the constraints. So there's going to be 3 different equations that are representing constraints in this particular situation. Now we're advantaged because we've been told that X and Y are the number of 2-drawer filing cabinets and the number of 5-drawer filing cabinets respectively. So now to practice constructing a table to show this relevant info. Well, what are they making? They're making cabinets. So the first column would be cabinets. The second column would be, I'd suggest that it would be the variables, number made. So there's 2 kinds of cabinets, 2-drawer and 5-drawer. That forms one column. The number made, we're given in the question, is X for the 2-drawer and Y for the 5-drawer. What's next? That's defining the variables. Basically, now we can start looking into the constraints themselves. So, number of drawers. So we're looking at the number of drawers constraint. The 2-drawer filing cabinet has 2 drawers in it. The 5-drawer filing cabinet has 5 drawers in it. So that's that column done. Number of drawers. Number of locks is the next constraint. We're limited to the number of locks we have in total. Both of them require 1 lock. And the last constraint is the sheet metal. And we're limited to the square meterage of it. The 2-drawer filing cabinet requires 2 square meters, and the 5-drawer filing cabinet requires 4 square meters. And we've put the info into a table. Now that doesn't seem that useful because you could have had that in your head anyway if you've written out those constraints. But what's extra useful about this, and what it doesn't show in your book, is that having a totals row shows you the constraints easily. Number of drawers, 2 times by the number of 2-drawer filing cabinets made, 5 times by the number of 5-drawer filing cabinets made, and the number of drawers you've got to play with is 34. The number of locks you've got to play with, even though each cabinet uses 1 and 1, the number of locks you've got to play with is a total of 8. And the amount of sheet metal total you've got is 42. So how is this useful? Well, to define the constraints, all you're basically doing is timesing each of these numbers by the number made. So if you work your way down, 2x plus 5y must be 34, 1x plus 1y must be 8, and 2x plus 4y is going to be 42. We just need to decide what direction the inequality is going to be. Well, they have this much material. They can't exceed that. They can only go up to it. They can make less than this material if they wanted. So all of the constraints would be less than or equal to. So our constraints are going to be the number made, x, has to be greater than or equal to 0. We can make 0 2-drawer filing cabinets. We can't make -1 of them. Y is greater than or equal to 0. We can't make a negative number of 5-drawer cabinets. And then the actual variables constraints here. Number of drawers. So the drawers constraint is 2x plus 5y is less than or equal to 34. So we can use anything up to 34 drawers. Total, and where does that come from? It comes from there. Total number of locks, 1x, so x, plus 1y, so y is going to be less than or equal to 8. Where does that constraint come from on our table? It comes from this column here. And then the last constraint is the total area of metal. In the last column there, 2 square meters times by the number of 2-drawer filing cabinets made, so 2x, plus 4 square meters times by the number of 5-drawer cabinets made, y is going to be less than or equal to 42. Where does that constraint come from? It comes from the final column here, and we just need to make note that anything we find there is going to be in square meters units, alright? So hopefully that helps you out with the idea of setting up constraints from a worded problem and the possibility of using a table to organize your thoughts so you don't miss out on anything. And yeah, I'll see you on the next video.